What up, guys, and welcome back, man. I don't know why I feel like it's been forever. It's probably only been about 5 minutes, but welcome back to erbsclass, man, for 5 more minutes of math. So last time we spoke, we were talking about those exponential equations, those exponential functions. Let's get to talking about the graphs. Why don't we? Okay, yes, exactly right. Graphs of exponential equations. So in this video, we're going to talk about a few things. We're going to talk about basic shapes. Yeah. Also, we're going to talk about key features. And then, of course, if we're talking about graphs, we got to talk about domain and range, of course. All right. Well, let's see how much you remember about exponential equations in the first place. Let's get that equation up here. What do all general exponential equations look like? Do you remember? Okay, yeah. I know that's a lot of information, but we also went over that information in that past video. So hopefully you know this by now. Yeah, this is what the equation looks like. And this is what the letters mean. Remember, A, the number outside the parentheses, the one not with the exponent attached. That's the starting point. Yeah, that's where we are when x equals 0. That's our initial value. That's our y-intercept on the graph. Yeah, you'll see that in a second. Remember, B, the thing that has the exponent attached to it, that's our rate of change, our exponential rate of change. Remember, it's our common factor. It's what we're multiplying by each time. Yeah, And remember, when that number in the parentheses with the exponent attached, when that number is bigger than 1, it's exponential growth. When that number is smaller than 1, exponential decay. Yeah, we talked about those. Now, let's see what those graphs look like. Okay. So this is what our coordinate axis might look like. And notice, so I gave these axes some labels, right? So you might see any of these labels on these axes. Let's talk about them real quick. You know, this vertical axis could be y, but remember, it could also be f of x. Remember, they're synonymous. A function, we're using the variable x, is the same as y, but sometimes with these exponential functions, you might see a t being used instead of x. That'll look just like this, except the variable being used will be a t. And you would see an f of t, and then you would see a t on this axis instead of x. Yeah, good. Okay, so let's get one up here, man. Let's see what this shape looks like now. Hopefully, you've graphed a couple of relations by now to know what exponential functions usually look like. Good. Now, maybe you've only graphed positive values. So if we were just focused on the first quadrant here, then we would be starting at this red point, right? And then just going up exponentially from there. That red point, that starting point where x equals 0, didn't we say that was this right here? Yeah, it is. Hold on. Yes. So that means this y-intercept, our starting point, our initial value, is the same as this number right here. Yeah. So if this number was a 2, guess what that number will be? A 2. Exactly right. If it were a 4, yes, then that number would be a 4. Now notice I wrote it like coordinates. So the x value will be 0, y value will be 4. Yeah. Now, okay, so we read from left to right. So notice how this graph is growing from left to right, right? So this right here will be an example of exponential growth. Yeah. I mean, imagine if we're multiplying this 4 times a number that's bigger than 1, wouldn't we be increasing every single time? And if we continue to multiply by that same number that's bigger than 1, we'll keep making it bigger and bigger and bigger and bigger. Yeah, exponential growth. So what would exponential decay look like? Good. Now, instead of continuously growing, let's imagine we're multiplying this 4 by a number smaller than 1, like 1/2. Half of 4 is 2, half of 2 is 1, half of 1 is 1/2, so we're constantly getting smaller and smaller and smaller, right? That's called decay. Now notice if b is greater than 1, if b is less than 1, what if b is 1? Would anything change? Let's multiply 4 by 1, 4, and then by 1 again, 4, and then by 1 again, 4. Yeah, nothing would change. Yeah. So when b is bigger than 1, it's a growth, and the graph will grow. Yeah. And when b is smaller than 1, it's called decay. Notice our starting point didn't change at all. That point right there is always the same as this number right here. Okay. Let's talk some domain and range real quick.